So today we're going to look at how to make chlorine gas in the lab and see some of its properties, and we're going to start off with the safety precautions that are needed: wearing goggles, gloves, an apron or lab coat, work in a fume hood. Only do this if you're a qualified chemist, chemistry teacher, and remember to be careful with concentrated acid as well as the product to make sure that it's cleared up correctly. So to begin with, we're going to look at the equipment. We start with the gas generator, which here is a jar or a flask with a tap funnel going into it and a delivery tube coming out of it. And for chlorine, the materials are concentrated hydrochloric acid in the tap funnel and potassium manganate 7, also known as potassium permanganate, in the bottom of the flask. And so you're going to describe what the reactants look like as you watch the movie. And so make sure you've got paper and can pause it to describe the appearance of the reactants. And how we're going to collect the gas depends on its properties. And for chlorine, it's soluble in water, so we can't bubble it through water. But it is denser than air. So if we collect it at the bottom of a container and it doesn't react with the air, it will displace the air upwards, which is what indeed will happen. So as you start to react the acid, you'll see a gas being produced, and you're going to describe the appearance of the gas that's produced. And we're putting some moist universal indicator paper at the top of the gas jar, and that enables us to determine when you actually have filled the gas jar or got an appreciable amount in it. So if you're lucky, you'll see it turn pink because of the acidic nature of the gas, but as it bleaches, it's going to turn it colourless. That's when enough chlorine is present. So view the video and write in your appearances. And now we go on to some properties, the theory of the reaction. And here you've got the word equation for the reactants and the products. You've got formulas and indeed the balancing coefficients for the reactants, and pause while you balance the whole equation. And then I want you to think, what other test reactions could you do with the chlorine? What might you react with the chlorine? What tests might you do safely in a fume hood? Just describe them, please. You can dissolve the chlorine in water, and here you see it forming HCl, hydrochloric acid, and HClO, hypochlorous acid. And that's going to be a solution of bleach. But never mix bleach with other cleaning products. It's dangerous as it can produce poisonous chlorine. So here we have it reacting with different elements. Finish that equation and you've got chlorine gas reacting with solid iron, here probably fine powder iron filings, making iron 3 chloride. And another equation reacting alkali metal lithium with chlorine gas and making lithium chloride. And to go into the theory, write the electron configuration of chlorine. If you go back to the first slide, you'll see a diagram of the Bohr model. And looking at the electron configuration that you've drawn, pause the video here to describe why chlorine is so reactive using the Bohr model. And then to look at the atomic structure. So list the number and type of subatomic particles for the 2 main isotopes of chlorine. And the average atomic mass is 35.45, so much closer to 35 than 37, which tells you a bit about the abundance of the isotopes. And looking at some properties and uses, it's a bleach and will kill bacteria, so useful for keeping pool water savoury, a toilet cleaner, and a surface cleaner for COVID-19 and anything else. Solutions are poisonous. It was used as a gas in World War I. A solution is a bleach, rendering some coloured fabrics colourless by oxidizing the dye. It's an oxidizer. It's a chemical that removes electrons from other chemicals. Look at its electron configuration to see why that might be the case. And reacts with most elements to make binary compounds, so the other metal, non-metal chloride, but doesn't react with the group 18 noble gases, except under the right conditions with xenon. And finally, you can also make chlorine with manganese 4 oxide and hydrochloric acid, and this reaction needs to be heated, so the preferential one in a fume hood, again, is to actually use the one that doesn't require heat with the potassium manganate 7. So pause to finish the equation and make sure you balance it. And with thanks to Washington International School Team Science and their IB chemistry students.